Yeah, good evening all. Back with our classes on amines. So let us write the next question. We were studying the basicity of amine. So please write the next question. Which is more stable, aniline or anilinium ion? Did you upload that yesterday's class? Which is more stable? Which is more stable, aniline or anilinium ion? We are asking what? Which is more stable? Whether aniline is more stable or anilinium ion is more stable. Yesterday we studied anilinium ion, NH3 plus. Where did we study anilinium ion? In nitration of aniline. We said that although NH2 is what directing group? Ortho and para directing group. It still gives metanitroaniline because in strong acidic medium, aniline gets protonated to form what ion? Anilinium ion. And this anilinium ion is what directing? Meta directing. Fine. So which is more stable? Aniline is more stable or anilinium ion is more stable? Please write. Anilinium ion is less stable than aniline because anilinium ion has only two resonating structures. Anilinium ion has only two resonating structures. Anilinium ion has only two resonating structures. Draw these structures. Chaitra, you can come and sit in front. If the board is shining or something, sit in front. You can see it easily. Because anilinium ion has only two resonating structures. One alternates starting from this side, one starting from the other side. Okay? Whereas aniline has 5 resonating structures. Whereas aniline has 5 resonating structures. Just now we do? Redraw them. Redraw them. Please redraw all the 5 structures of aniline. Redraw the structures of aniline. Just now we did it. Innonsali practice agutte maadi. Movements ಗೊತ್ತಾಗಬೇಕಂದ್ರೆ ಮಾಡಿ. Nothing will go wrong. So it has how many resonating structures? 1, 2, 3, 4, 5. 5 resonating structures. After that, write greater the number of resonating structure, greater the number of resonating structures, greater is its stability. number of resonating structures, greater is its stability. So, we have studied alkyl amines are a stronger base than ammonia. Why? Because of what effect? Plus I effect. Aryl amines are a weaker base than ammonia. Which effect? Minus I effect. Because minus I effect of which group? Phenyl group. Okay. And the electrons move towards the benzene ring. As a result of it, the electron is not available on nitrogen for donation. Hence, aryl amines are a weaker base than ammonia. Clear till here? Now, we have studied between aniline and anilinium ion, which is more stable. Aniline is more stable because it has more number of resonating structures. Now, write the most important basic strength of primary, secondary and tertiary amine. Basic strength of primary, secondary and tertiary amine in aqueous phase. Basic strength of primary, secondary and tertiary amine. Heng barithira? Basic strength of 1 degree, 2 degree and 3 degree amines in aqueous phase. Basic strength of primary, secondary and tertiary amine. Primary amine, secondary amine and tertiary amine in which phase? Aqueous phase, or when they are dissolved in water. In gaseous phase it is different, in aqueous phase it is different. So one question on basicity will 100% come. You have to see whether they are asking you in aqueous phase or they are asking you in gaseous phase. So write first. The basic strength of amines in aqueous phase. The basic strength of amines in aqueous phase is decided by 3 effects. Is decided by 3 effects. First, inductive effect or plus I effect. Inductive effect or plus I effect. Okay, now first understand and then we will write. When I talk about plus I effect, first is RNH2. Second is what? R2NH. And third is what? R3N. This is what is my primary, secondary and tertiary amine. This alkyl group is an electron releasing group. It shows what effect? Plus I effect. As a result of it, it transfers all its electron over the nitrogen atom. So the electron density over the nitrogen atom increases and it is easily available for donation. As a result of it, it is a very better base than ammonia, or it is a Lewis base. Take more the number of alkyl group, more stronger is the inductive effect, and hence this will be a stronger base than primary amine. When it comes here, it has 3 alkyl groups and hence the strength of inductive effect here is maximum. So on the basis of plus I effect, the order of basicity of amines in aqueous phase is tertiary, greater than secondary, greater than primary. Understood what I said? Once again, plus I effect means what? Electron releasing effect. All the alkyl groups will release the electron towards the nitrogen atom. As a result of it, the electron density over the nitrogen atom increases. And the nitrogen electron, the lone pair of electron of nitrogen is easily available for donation. More the number of alkyl group, more is the strength of inductive effect, and it is more easier for the nitrogen to donate the pair of electron. So on the basis of plus I effect, the basicity should be in the order of tertiary, greater than secondary, greater than primary, greater than ammonia. Fine? Let us write. Idin barkondu first. Spread out ಮಾಡಿ ಬರಿಬೇಕು. Only structure ಬರೀರಿ first. Please write. It increases the basic strength of amines. It increases the basic strength of amines by increasing the electron density. It increases the basic strength of amines by increasing the electron density over the nitrogen atom. By increasing the electron density over nitrogen atom. More the number of alkyl groups, more the number of alkyl groups, more stronger is the inductive effect, or more stronger is the plus I effect. And it is easier to donate the lone pair of electrons over the nitrogen atom. It is easier to donate the lone pair of electrons over the nitrogen atom. Therefore, the order of basicity according to plus I effect. Therefore, the order of basicity according to plus I effect is what? Tertiary, greater than secondary, greater than primary, greater than ammonia. Is this part clear? So the first effect which governs the basicity of amines in aqueous phase is what effect? Plus I effect. Next, hydration effect or solvation effect. Second effect is right, hydration effect or solvation effect. Hydration effect or solvation effect. Hydration or solvation effect. Fine. Now let us understand what do you mean by hydration or solvation effect. Again, we will draw a structure of primary, secondary and tertiary amines. Hydration effect is the availability of these hydrogen atoms so that they can easily bond, hydrogen bonding with the next water molecule or with the next amine. Okay? So, as how many atoms of hydrogen are present here? 2 atoms of hydrogen there, 1 atom of hydrogen here and no atoms of hydrogen here. The hydration or solvation effect is maximum in primary, then in secondary and nothing in tertiary. Because there is absence of hydrogen atom in tertiary, as a result of it, you will find that it cannot form any hydrogen bonds. So, according to the solvation or hydration effect, the order is primary, greater than secondary, greater than tertiary. Understood? It is basically dependent on these hydrogen atoms which will help in bonding the molecule with the help of what bonds? hydrogen bonds, intermolecular hydrogen bonds. As there is no availability of hydrogen, this generally will not be in a interbonded form with other tertiary amines. Please write. Hydration effect or solvation effect. Primary amine shows maximum hydration effect as it has two hydrogen atoms, to form hydrogen bonds with water. Secondary amines, continue the sentence or write the next sentence. Secondary amines have one hydrogen atom and tertiary amines do not have any hydrogen atoms to form bonds with water. Hence, the order of solvation effect is primary greater than secondary greater than first work on ammonia first. Ammonia greater than primary, greater than secondary, greater than tertiary. How do you form hydrogen bonds? This H will pull on the oxygen and form what bonds? Hydrogen bonds. Here, as it is only one H, it will form only one bonds. Here, there is no possibility of finding bonds with water molecule, as there is presence of no hydrogen atom. And in ammonia, if I have to draw, it will be gone. At every place, I can bond it with oxygen. Hydrogen bonded with oxygen. Did you understand what is extent of solvation? Extent of solvation is the ability of this hydrogen present in amines to form what? Bonds with water molecule. Through which bonding? Intermolecular hydrogen bonding. Is it clear? You can draw these structures. Please draw. Pritam, Amo, Shreya, ellargu idde. Pritam andre sakkata agile beta. Shreya also. Please write extent of bonding. In textbook they have taken ions. So there is RNH3 plus, R2NH2 plus, because they are explaining the stability of the ions. I have not taught you with the ions, so don't think that I have taught wrong and in the textbook something else is given. They have taken ions. When you take ions, it will become NH4 plus, RNH3 plus, R2NH2 plus, R3NH plus. One H will be added in ions because it is all protonated. Okay? Now write the third effect. Steric hindrance. So our first effect said what? Tertiary greater than secondary. greater than primary, greater than ammonia. Plus I effect. Second effect, which is hydration effect, said what? Ammonia, then primary amines, then secondary amines, then tertiary amines. Now the third effect which governs, the first was what effect? Plus I effect. The second is what effect? Hydration or solvation effect. And the third is what? Steric hindrance. The third effect which we have to study is what? Steric hindrance. It is very, very important, the basicity of amine and all the three effect which is involved in the judging of basicity. Steric hindrance. In yellow helkottidna. Do you remember steric hindrance? Larger, bulkier groups overcrowding the atom is called as what? Steric hindrance. In which it will be more? See, first one is what? NH3. No alkyl groups. Correct? Second one is what? RNH2. Only one alkyl group. Then R2NH. Then what? R3N. Where there is more alkyl group present? Tertiary. So which will show maximum steric hindrance? Tertiary. So according to steric hindrance, what is the order? Tertiary, greater than secondary, greater than primary, greater than ammonia. Why it is difficult for the lone pair electron there to do any activity? Because the larger groups, let us suppose C3H7 or C4H9 alkyl group is present. As a result of it, there is confusion between the electrons of all the alkyl groups. As a result of it, what happens? There is electron-electron repulsion and the lone pair is easily not available for donation. According to what effect? Steric hindrance. So it is maximum in case of tertiary amines, then secondary amines, then primary amines, and not at all present in ammonia. Please write. The basic strength of amine, heading steric hindrance baribeku. The basic strength of amines depends on the ease with which protonation of amines takes place. The ease with which protonation of amines takes place. The presence of bulkier groups, of bulkier alkyl groups, hinder protonation. This hindrance is called steric hindrance. More the alkyl groups present in amines, more the alkyl groups present in the amines, more is the steric hindrance. More is the steric hindrance. And hence, the order of steric hindrance is, tertiary greater than tertiary greater than secondary, greater than primary, greater than ammonia. Is all the three effects clear? First was what? Plus I effect. Plus I effect, more the alkyl groups, more is the inductive effect. Second was solvation effect. which is maximum in case of ammonia, then in primary amine, then in secondary amine, and then in tertiary amine. Third is that steric hindrance is maximum in case of tertiary amines, but basicity of tertiary amines will be very, very less. Okay, but steric hindrance is maximum in case of tertiary, then secondary, then primary. Now write, in aqueous phase, all the three effects play a prominent role and the net results of all the three effects the net result of all the three effects is secondary greater than primary greater than tertiary greater than ammonia. If you compile all the three effects, you will get the result as what? Secondary amines greater than primary amines greater than tertiary amines greater than ammonia. Okay, alright. In case of methylamines, CH3 twice NH greater than CH3 NH2 greater than CH3 whole thrice N and greater than ammonia. This order has to be learnt. In methylamine it is what? Secondary, then primary, then tertiary, then ammonia. Very. In case of ethyl amines, with an increase in the carbon atom, there is increase in inductive and steric hindrance. There is increase in inductive effect. There is increase in inductive effect and steric hindrance, and the order changes to secondary greater than tertiary greater than primary greater than ammonia. So C2H5 whole twice NH greater than C2H5 whole twice N greater than C2H5 NH2 greater than NH3. Order change ಆಗುತ್ತೆ. So question na neater ಓದಬೇಕು. What in order in case of primary amines, that is methylamine, order in case of ethylamine changes. Is it clear? You cannot generally write. This entire thing comes for 5 marks in PU board. Basicity of amines in aqueous phase. You have to write so much. We can see 1 page. Okay. So you have to write what are the three effects plus I effect. You can reduce accordingly. Okay. I have made you write long so that you understand. You can shorten it up. But it is required to write plus I effect, solvation or hydration effect, steric hindrance, order in case of methylamine, order in case of ethylamine. In case of methylamine, it is secondary, primary, tertiary and ammonia. In case of ethylamine, it is secondary, tertiary, primary and ammonia. Clear? This is a very important concept. If you have understood, and this video you can see later when you are seeing amines. Okay? Now write basicity of amines in gaseous phase. Basicity of amines in gaseous phase. So we studied 3 effects. Which were the 3 effects? Plus I effect, hydration effect and steric hindrance. Hydration effect is of no use in gaseous phase. Gaseous phase में hydration effect क्यों applicable नहीं है? Because there is no water. and hence there is no intermolecular hydrogen bonding with water. So only two effects play the role during what? Gaseous phase. What are the two effects? In plus I effect and steric influence. So the order of both was what? Tertiary, greater than secondary, greater than primary, greater than ammonia. So in gaseous phase, it is always following the order tertiary, greater than secondary, greater than primary, greater than ammonia, because there is absence of what effect? Hydration effect or solvation effect, right? If you are unable to do it, please go and wash your face. In gaseous phase, there is no hydration effect, and hence the order is tertiary, greater than secondary, greater than primary, greater than ammonia. Okay, I have not described the first two effects, but when you write, you will describe the first two effects and you will write that hydration effect is absent. You cannot directly start from here. Understood? No? Alright. Therefore, in methylamines, it is CH3 whole thrice N stronger than CH3 whole twice NH, stronger than CH3 NH2, stronger than NH3. Trimethylamine, stronger base than dimethylamine, which is a stronger base than methylamine, which is a stronger base than ammonia. Is it clear? In aqueous phase, the order changes as dimethylamine, greater than methylamine, greater than trimethylamine, greater than ammonia, because of the three effects. In the gaseous phase, it follows the standard logic of tertiary, greater than secondary, greater than primary, greater than ammonia. Why? Because there is absence of what effect? Hydration or solvation effect. Now please write the last part of amines. In case of substituted amines, and if I ask you to continue the order and I keep aniline is a weaker base than ammonia. So aniline will come, all aromatic amines will come after ammonia. Okay, if I give you the order, all aromatic amines will come after ammonia. Please write. In case of substituted aniline, electron releasing groups like CH3, write like this, like CH3, like OCH3, increase the electron density on the nitrogen atom and increases the basic strength. Next point, the presence of electron withdrawing group. The presence of electron withdrawing group on amine, such as NO3, SO3H, COOH, and X. What is X? Halogen. Decrease the basic strength. So this finishes the entire chapter of amines. Till here only we have and if you want, we will give you notes of that diazonium salt. ಅಮ್ಮ ತೆಗಿಯೋ ಒಂದು ನಿಮಿಷ ಅದರಿಂದ ಸ್ಟಾಪ್ ಮಾಡು.